I'm B. Praveena, Assistant Professor of Mathematics in Institute of Aeronautical Engineering College. Today in this session, we will discuss about the topic on double integral. It is very interesting topic. Okay, what is the form of the double integral directly here? Double integral means two integrals, either with respect to xy or yz or zx. From through the definition here, the first one, when y1, y2 are functions of x. Okay, what is the first definition here? When y1, y2 are functions of x and x1, x2 are constants. Okay, if the functions are in x and x1, x2 are constants, for that case, f of xy is first integrated with respect to y, keeping x fixed between limits y1 and y2, and then the resulting expression is integrated with respect to x within the limits x1 and x2. I'll explain clearly here. Once you observe double integral of f of xy dx dy. For that case, once you observe y1 and y2 are, whatever the first integration, y1 and y2 are in terms of x. In terms of x. For that case, first integrate with respect to y. First integration with respect to y, and after that integrate with respect to x. What we have to observe here, x limits are constants and y limits are in terms of x. Therefore, for this case, first integrate with respect to y, and after the integration with respect to and substitute the limit points, then it will be the resulting as converted in terms of x, and after that integrate with respect to x and then substitute the limits of x. That's the final answer for the double integral of f of xy dx dy is dy. Okay, next concept, when x1 and x2 are functions of y. Okay, when x1 and x2 are functions of y and y1 and y2 are constants, f of xy is first integrate with respect to x, keeping y fixed within the limits x1 and x2, and then resulting expression is integrated with respect to y between the limits y1 and y2. What about the second definition for the double integral? Once you observe here the first integration, and the first integration and the limit points are, x limit points are in terms of y. X limit points in terms of y. That's why first integrate the function with respect to x. Okay, and whatever the second limit points here, y are constant. What are the y limits here? Constant. X is in terms of y as the first limits and y as constant. For that case, first integrate with respect to x, then substitute the limit points. Okay, for the x, then the given function will be converted in terms of y. After that, integrate with respect to y and then substitute the limit points are constants. Okay, that's the result for the second definition. Okay, what is the difference between these two? Once again, I'll repeat here. For the first definition here, y is in terms of x. Y and 2 are the functions of x and x1, x2 are the constants. For that case, first integrate with respect to y and after that integrate with respect to x. And the second case here, when x1 and x2 are functions of y, when x1 and x2 are functions of y and y1 and y2 are constants. For that case, first integrate with respect to x and substitute the limit points, then the result will be converted in terms of y, and after that integrate with respect to y and substitute the y limit points are constant. Then we got the final answer for the second formula. Okay, this is the procedure for the first one and second one, and the third one, okay, no need, only two are there. First one is in terms of y1, y2 are in terms of x and x as constants, and the second one is x is in terms of y and y limits are constants. Now I'll go through the problems through these definitions. Okay, evaluate double integral of xy x plus y into dx dy over the region R bounded by y is equal to x square and y is equal to x. Here once you observe the first question, there is any limits directly in the question? There is no limits. But they are given some conditions. What are the conditions here? Over the region, okay, R bounded by y is equal to x square and y is equal to x. That means from these curves, from these conditions, first I'll calculate the limit points. Okay, na? After that, okay, evaluate double integral of the given function xy of x plus y into dx dy. This is the concept of the first question. That means for the first question, here without limits. Okay, with limit questions also there in this topic. That is second topic. First I'll discuss without limits. Without limits means from the given conditions, I'll take the limit points. Okay, what are the conditions here? They are given some curves. What type of curves they are given here? Y is equal to x square and y is equal to x. From that, okay, first I'll calculate the limit points where the two are intersecting. Okay, here once you observe y is equal to x square is a parabola through 0, 0 symmetric about y-axis. Already we know that y is equal to x square means that is generally we know that it is symmetric about y-axis. And what about y is equal to x? That is the straight line equation. That is a straight line equation which is in the form of y is equal to mx plus c, but c is 0. That means here y is equal to x is passing through origin. That is 0, 0, and which is in the form of y is equal to only mx. What is m here? 1 into x. Therefore, slope is equal to how much? 1. Okay, from these curves where the two are intersecting, now I'll find out that intersecting points from the diagram. Okay, let us find their points of intersection solving y is equal to x square and y is equal to x. Once you observe from the two curves y is equal to x square and y is equal to x, from the first equation, let us take y is equal to x square as the first equation. Here I'll write y is equal to x square as the first equation and the second equation is y is equal to x. From that, first I'll solve these two equations and solving either x points or y points. Okay, once you from the second equation, what is y? Y is equal to x. Substitute this y is equal to x in the first equation. Okay, then easily that equation will be converted in terms of x. Okay, substitute 2 in 1. That is y is equal to x, right? That means x square is equal to x. That is this. X square is equal to x. From that, x square is equal to x. X square I'll write simply that as x square minus x is equal to 0. From that, what is common here? X common, right? That is x minus 1 is equal to 0. From that, x is 0 and x minus 1 is equal to 0. I'll equate both the terms with 0. That is here x is 0. We got 1 point for the x and x is equal to 1. Therefore, what are the points for x here? X is equal to 0 and x is equal to 1. If you know the x limit points, okay, then easily we get y limit points from the curve equations. Okay, from that, x is equal to 0 and x is equal to 1. Substitute in any equation either first or second. Better to substitute second equation. Easily we got that. At x is 0. At x is 0, substitute in second equation, that is y is also 0. At x is 1, at x is 1, substitute in the second equation, that is y is also 1. Therefore, at x is 0, we got y is 0. At x is 1, we got y limit point as 1. Therefore, the point of intersections of the curves are 0, 0 and 1, 1. Okay, I'll clearly explain that intersection points on the diagram. Okay, but from the through the solution, through the calculation, we got the intersecting points. Not only intersecting here, intersection of the curves are 0, 0 and 1, 1. Okay, now I'll draw the diagram for that. Okay, evaluation of the integral. Okay, sorry, what is the diagram here? Once you observe, y is equal to x square, right? That y is equal to x square. From that, at x is 0 and y is 0. Okay, this is y is equal to x square is symmetric on y axis, right? This is symmetric on y axis. And what about the y is equal to x? That is the straight line, it is passes through the origin. Okay, where the two are intersecting. Okay, before the calculation we got that intersecting points at 0, 0 and 1, 1. These are the intersecting points for the parabola and the straight line. Okay, from that diagram, now we can take the limit points of y and x. Okay, now we can take the limit points of y and x from the diagram. Okay, from the diagram, okay, this is equal to what? This is parabolic equation is y is equal to x square and this is y is equal to x. From that first, now from the diagram I got the intersecting points, that is 0, 0 and 1, 1, and that same diagram I'll take the limit points of y and x. How I'll take here? Evaluation of the integral, we first integrate. Okay, we first integrate with respect to y from, okay, valuation of the integral, we first integrate with respect to y. Okay, that means from the given two curves are in terms of y, from that I'll take upper point and the lower point. Okay, here what is upper point and the what is lower point here? Here the upper point from the diagram, y is equal to x. This is the upper point. And what about the lower point from that? This is y is equal to x square. Therefore, what are the limit points for that? Limit points, y is equal to x square to y is equal to x. Okay, y is equal to x square to y is equal to x. If you are taken y limits in terms of x means, then you can take x limits are constants. From the diagram, what are the x points here? X limits are constants. That means x is equal to 0 and x is equal to 1. Okay, therefore x limit points are 0, 1. Okay, therefore the x limit points are 0, 1. From once you see here, y is in terms of x and x limits are constant. That means this is the first formula in the double integral, right? That's why I'll take the question now. Double integral of xy into x plus y into dy dx. That's the question. Double integral of xy into x plus y into dy dx. This is the question. Okay, from that, first I'll take the y limit points from the diagram in terms of x. That means y is equal to x square to x and the x limit points are 0 to 1. X limit points are 0 to 1. From that first integrate with respect to y. Okay, from that first integrate with respect to y. Okay, that is first I'll multiply inside the bracket with xy, that is x is equal to 0 to 1 and y is equal to x square to x, that is x square y plus x into y square dy dx. x square y plus xy square into dy dx. Okay, now integrate first with respect to y. Okay, this is this one. Now, okay, first integration with respect to y means x square is constant with respect to y. Therefore, y integration is what? Y square by 2 plus x is constant with respect to the integration of y, that is y square integration is y cube by 3. Therefore, what are the limit points for that? Y is equal to x square and y is equal to x. Now substitute the limit points, that is the next step. Now substitute the limit points, that is y is equal to x and y is equal to x square. I'll write that step here. X is equal to 0 to 1. Okay, x square y square by 2 plus x into y cube by 3. Limit points are x square to x. Alright, x square to x dx. From that, I'm substituting the first upper limit point as y, that is x is 0 to 1. X square of y square means x square by 2 plus x into y cube means x cube by 3. It's the upper point, and minus of x square into y means x square whole square by 2 plus x into x square whole cube by 3 into dx. From that x is equal to 0 to 1. X is equal to 0 to 1. X square into x square, that is x power 4 by 2 plus this is x power 4 by 3. X power 4 by 3 minus of here x square and x power 4, that is x power 6 by 2. X power 6 by 2 plus x power 6 into x, that is x power 7 by 3 into dx. From that, x is equal to 0 to 1 x power 4 by 2 plus x power 4 by 3 minus x power 6 by 2 minus x power 7 by 3 into dx. Once you observe, after substituting the y limit points here, then the function will be converted totally in terms of x. Then now integrate with respect to x. Okay, now integrate with respect to x. That is x is equal to 0 to 1. Okay, now these two are x power 4 terms. I'll take directly here 2 3 LCM as 6, that is 3x power 4 plus 2x power 4 minus x power 6 by 2 minus x power 7 by 3 into dx. From that, x is equal to 0 to 1. This is 3x power 4 plus 2x power 4, that is 5x power 4 by 6 minus x power 6 by 2 minus x power 7 by 3 into dx. This is this. Okay, once you observe, total it will be converted in terms of x. Now integrate with respect to x. What is the integration of x power 4? That is, I'll take 5 by 6 outside, and x power 4 integration is x power 5 by 5 minus x power 6 integration is what? That is x power 7 by 7. Okay, I'll write that step here, that is x is equal to 5 into 5 by 6 into x power 5 by 5 minus x power 7 by 7 into already here 2 minus x power 8 by 3 into 8 into what are the limits for that? 0 to 1. Okay, from that 5 by 6 into x power 5 by 5. Okay, that is simply say x power 5 by 6 into 5 how much? I'll write directly this as 30 minus x power 7 by 14 minus x power 8 by 24. Okay, that is 5 into x power 5 by 6, 5 is a 30, that is 30 minus x power 7 by 14 minus x power 8 by 24, and the limit points 0 to 1. Okay, now substitute the limit points here. Then the final next step here 5 into, I'll substitute here, that is 1 power 5 by 30 minus 1 power 7 by 14 minus 1 power 8 by 24. If you are substituting the lower limit, that is completely 0. From that, okay, anyway here 5 cancel, or 6 5s are 30. Okay, I cancel here, that is 5 6, that is 1 by 6 minus 1 by 14 minus 1 by 24. 1 by 6 minus 1 by 14 minus 1 by 24. What is the LCM for 6, 14 and 24? That is 168. That is 168. After taking the LCM, it is 28 minus 12 minus 7. That is 28 minus 19. 28 minus 19 as 9 by 168. Okay, that is 3 3s are 9, 3 5s are 50, and 3, that is 3 by 56. 3 6 are 18. 3 3s are 9 and 3 5s are, and 3 6 are 18. Therefore, the final answer for the first question, that is 3 by 56. Okay, evaluation of the double integral without the limit points. They are directly given, okay, parabolic equation and the straight line equation. From the two, first I'll take the intersecting points, and from the diagram I'll take the limit points for y, which is upper limit and which is lower limit. From the diagram only easily we got that upper point and lower limit for the y, and after that I am taking the x limits and I'm substituting the points in the given question, and after the integration we got the final answer as 3 by 56. This is the first question answer for the double integral form. Okay, now I'll continue the second question for the same topic, that is evaluate double integral of xy dx dy, where R is the region bounded by x-axis and x is equal to 2a, and the curve here, and the curve x square is equal to 4ay. Once you observe here, x square is equal to 4ay is also one parabolic equation, and the line is here x is equal to 2a. Same procedure is same as previous question. Okay, first from that equations where the two are intersecting, then you can find out the limit points, and after that from the diagram which is upper point and which is lower point, then you can take. Okay, from that the line, what is the line? Given equation. Okay, given line equations are here x is equal to 2a, and the parabola x square is equal to 4ay, where the two are intersecting 2a comma a. Okay, where the two are intersecting directly here 2a comma a, I'll write here, that is x is equal to 2a and x square is equal to 4ay. Now I'll substitute in place of x as 2a, that is 4a square is equal to 4ay, that is 4ay minus 4a square is equal to 0. From that I'll take 4a common, that is y minus a is equal to 0. That is for the first point here, wait, 4a square minus 4a into y, x is equal to 2a. From that y is equal to a, and the next one 4a as 0. Okay, therefore what about y here? Y is equal to a. If you are taken x is equal to 2a, x is equal to 2a, we got y point is what? A. Therefore, the line x is equal to 2a and the parabola x square is equal to 4ay intersecting at which point? 2a comma a. Okay, then the given integral double integral of xy dx dy. Let us fix. Okay, let us fix first y for a fixed. Okay, from the diagrams, okay, from the conditions, I got the intersecting points that are 2a comma a. From that question, what is the question? Double integral of xy into dx dy. From the question, first I fixed, okay, x varies from, here I'll fix y, and x is varies from 2 root ay to 2a, then y is varies from 0 to a. How? From the diagram, I'll explain clearly here. Once you see here the diagram, x square is equal to 4ay. This is x square is equal to 4ay, and the line x is equal to 2a. That means here I'll take x is equal to 2a and y is equal to a. Okay, that means I'll draw the diagram here at x is 2a. At x is 2a and x square is equal to 4ay. Okay, from the two are intersecting exactly at what? 2a comma a. Okay, the two are intersecting at 2a comma a. Therefore, from that, which is the upper point and which is the lower point? First, I'll fix y. That means I'll consider y limits are constant for this question, and x limits are varies from in terms of y. That means here the lower limit as 4ay and the upper point as 2a. Once you see, observe, this is the area. Now we can calculate, okay, this value. That's why here, which is the upper point and which is the lower point? This is the lower point and which is the upper point. From that, I'll take, okay, limit point as x is equal to 2 root ay. X square is equal to 4ay means what? 2 root ay 2. Okay, x as 2a. Therefore, x limit points 2 root ay to 2a. 2 root ay to 2a. And what about the y limit points here? Y limits are fixed. Okay, that means y limit points from the diagram here 0 to a. Limit points are 0 to a. Okay, this is the end point of that. Here 0 comma a are the y limit points. Okay, now substitute that limit points from the question, that is integral of xy dx dy. Now I'll fix it here y, and x is varies from, okay, 2 root ay to 2a. That means I'm using for this second question double integration of the second concept, second definition. Okay, from that x is in terms of y, and y limit points are 0 to a, xy into dx dy. Okay, now integration whether with respect to x or y here, definitely first integrate with respect to x here. Okay, definitely here integrate with respect to x. That means here y into x integration as x square by 2, and the limit points are 2 root ay into 2a, and y limits points are constant, that is integral y is equal to 0 to a dy. Okay, that is this one. Okay, y of x square by 2, 2 root ay by 2a. Now I'm substituting first x limit points, that is first upper limit point as 2a, that is 2a square. Okay, I'll write that step here. Okay. To x square by 2, and the limit points are 2 root a by 2, 2a. Into dy, that is 2a whole square by 2 minus 2 root ay whole square by 2. Integral of y is equal to 0 to a dy. Okay, then y is equal to 0 to ay. Here 2 cancel. Okay, 2 cancel. Then we got 1 2 only, that is 2a square minus here 2 4a y by 2. Then 2 cancel again here, that is y is equal to 0 to a 2a square minus 2ay into y into dy. This is this. Okay, after the integration with respect to x and after substituting the limit points of x, we go directly here. Y is equal to 0 to a, 2a square minus 2a y into already here 1 y, that is y. Okay, the next integration with respect to y. Next integration with respect to y, that is 2a square into, okay, first I'll multiply inside the bracket with y minus 2a into y square, and the limits integration of y is equal to 0 to a dy. That is 2a square into y integration as y square by 2 and 2a into y cube by 3. And the limits are 0 to a. Now substitute the limit points here. 2a square into a square by 2 minus 2a into a cube by 3. We are substituting the upper limit, that as a got 2a square into a square by 2 minus 2a into a cube by 3. We are substituting the lower limit, that is completely 0. Here 2 cancel, that is a power 4 minus 2a power 4 by 3. That is this. A power 4 minus 2a power 4 by 3. Now I am taking the LCM of that, that is 3 is LCM, that is 3a power 4 minus 2a power 4. That is equal to how much? That is a power 4 by 3. Okay, this is the solution for the second question, that is in double integral of xy into dx dy. The answer is a power 4 by 3. This is the concept for the double integral. For the first question, okay, for the first question I'll fix there x limits and y is varies from the x square to x. From the second question I fixed y limit points and x is varies from y limits. Okay, that's the concept of the two questions. Okay, next continuation of the question is third one, that is evaluation of double integral of y into dx dy over the region R bounded by y square is equal to 4x and x square is equal to 4y. Y square is equal to 4x and x square is equal to 4y. Once you observe, these two are which type of equations? The two are parabolic equations. Okay, from that parabolic equation, first we have to take the intersecting points of the two, and after that from the diagram which is upper and which is lower point, then take. Okay, then the answer for this here let us take y square is equal to 4x, that is the first parabolic equation, and the second one as x square is equal to 4y. Let us take that as the second equation. Okay, from that, okay, now I'm solve 1 and 2. Solve 1 and 2. Same as previous questions procedure. Solve 1 and 2. How to solve here? Here y square is equal to 4x form. Here x square is equal to 4y form. Substitute values 2 in 1. That means if you are substituting 2 in 1, easily the equation will be converted in terms of x. Okay, that's why I'll substitute here. Here from that second equation, what is x? What is y? Y is equal to x square by 4. What is y here? X square by 4. Now substitute, this is in the second equation, that is first equation, that is y square is equal to 4x. In place of I am substituting here x square by 4 whole square is equal to 4x. From that x power 4 by 16 is equal to 4x. From that x power 4 is equal to, taking cross multiplication, that as 16 4s are 64 into x. From that x power 4, I'm writing 64 into x is equal to 0. From that I'm taking what is common here, x is common, that is x cube minus, I'll write simply this as 4 cube is equal to 0. From that I'm equating both the terms with 0. that is x is equal to 0, x is equal to 0 and x cube minus 4 cube is equal to 0. From that, what is x? X cube is equal to 4 cube. From that, x is equal to what? 4. Therefore, here x is equal to 0 and x is equal to 4. These two are the x points at x is 0 and x is equal to 4. If you know the x limit points, then you can calculate y limit points from the first equation or the second equation. Now, I am substituting x point and x 2.0 comma 4 in the first equation. Okay, substitute x is equal to 0 in the first equation. In the first equation, that is, substitute x equal to 0 in the first equation, that is, y is also 0. If we have taken x is 0, we got directly y is also 0. Therefore, what about x comma y here? 0 comma 0. Therefore, x comma y as 0 comma 0. And next, substitute x is equal to 4 in the first equation again. Okay, that is, what is this first equation here? Y square is equal to 4x. That is, y square is equal to 4 into 4. That is, y square is equal to 16. Therefore, what is y? 4. Therefore, if you have taken x is equal to 4, we got y as 4. Therefore, at x is comma y points are 4 comma 4. Therefore, what are the intersecting points here? Intersecting points are 0 comma 0 and 4 comma 4. Therefore, here intersecting points 0 comma 0 and 4 comma 4. Now I'll draw the diagram. Okay, now I'll draw the diagram for both the curves. Here, what are the curves here? Parabolic equations, that is y square is equal to 4x and x square is equal to 4y. That is y square is equal to 4x. This is y square is equal to 4x and x square is equal to 4y. X square is equal to 4y. This is, okay, y square is equal to 4x and this is x square is equal to 4y. Okay, from the diagram now, okay, from the two curves, now we got the intersecting points. What are the two intersecting points here? 0 comma 0 and 4 comma 4. Okay, these are the two curves intersecting points. Okay, now from the diagram where the two are intersecting, here this is the area. Now from this I'll take the limit points either x or y. Okay, then from that, okay, here I'll take the limit points for the y limit points. Here, which is upper point and which is the lower point? Here, upper limit as, lower limit as it touches exactly y square is equal to 4x. That means y is equal to what? 2 root x. And what about the lower point here? X square is equal to 4y. That means, okay, here I'll take, which is x square is equal to 4y as, from that directly I'm writing here y limit points x square by 4 to x square by 4 to 2 root x. Y limit points from that x square by 4 to 2 root x. Okay, therefore the lower point as x square by 4 and the upper point as 2 root x. Next, what about the x limit points here? X limit points 0 to 4. 0 to 4. I'll take this is lower limit and this is upper limit. Okay, that is x square by 4 to 2 root x, right? Y limit points are x square by 2 root x and x limit points are 0 to 4. That means for this question, I'll fix x limit points are the constants and y limit points are varies from x square by 4 to 2 root x. Okay, x square by 4 to 2 root x. Therefore, the given question is here double integral of y into dx dy. That is equal to simply here x limit points I'll fix it, that is 0 to 4, and y limit points x square by 4 to 2 root x. X square by 4 to 2 root x. Here the function is only y into dx dy. Okay, from that now I'll integrate first with respect to y, that is y integration as y square by 2, and the limit points are x square by 4 to 2 root x, and x limit 0 to 4 into dy. Okay, that is dx. Okay, that is dx, that is x is equal to 0 to 4. Now substitute the y limit points here, that is directly I am writing that 4x minus x power 4 by 16 into dx. After substituting the y limit points here, directly we got 4x minus x power 4 by 16 into dx. Okay, from next integration with respect to x, that is x is equal to 0 to 4, 4x minus x power 4 by 16 into dx. From that, integrate first with respect to x, that is 4 into x square by 2 minus x power 5 by 5 into 16, and the x limit points are 0 to 4. Here 2 to cancel, that is 2 into 4 square minus x power 5, that is 4 power 5 by 5 into 16. And if you are substituting the lower limit, that is 0, from that case here we got the final answer for this 48 by 5. Okay, 48 by 5. Okay, therefore from the last question here, double integral of y into dx dy over the region R bounded by, okay, the two are parabolic equations. From that we got the final answer as 48 by 5. Okay, this is the procedure for finding double integral without limits. Okay, thank you for all.
Like, share and subscribe. Hit the bell icon for more updates.